In this video, I will discuss JEE Main PYQs based on projectile motion. So in a projectile motion, a mass is thrown from the surface of the earth. It takes a trajectory like this and again hits the ground here. So the parameters of the projectile motion are, the range are the horizontal distance covered and the maximum height it attains in the middle of the flight, and the flight time, capital T. So the thing is thrown with a velocity u at an angle theta with the horizontal or the ground surface. So we can consider u and theta as inputs. So we should be able to calculate the range with the maximum height attained and the time of flight in terms of the input u and theta. The range is the horizontal distance covered with the horizontal velocity is u cos theta, and in the horizontal direction there is no acceleration. It's a uniform motion because the only force that's acting on this mass is gravity, which is vertically downwards. So this will affect the vertical motion, not the horizontal motion. So horizontal motion is a uniform velocity motion. So the horizontal distance covered is the uniform velocity in the horizontal direction with the total flight time t. To get the flight time, we'll use the vertical motion and take these 2 points, ground in the maximum height point. So the time it takes to go from here to here is half the flight time by symmetry. It's t by 2. So writing v equal to u plus et in the vertical direction between these 2 points. So at this maximum height point, the vertical velocity is 0 because initially the vertical velocity is u sine theta. After that, keep on decreasing because the gravity is opposing this motion. At the topmost point, the velocity is 0 and initial velocity in the vertical direction is u sine theta. Acceleration is downwards, upward direction is taken as positive for the y direction. So acceleration is minus g. And the time between these 2 points is half the flight time. So from this, the flight time will come out to be two u sine theta by g. So using that thing here, the range of the motion is u square by g and then 2 sine theta cos theta, that is sine 2 theta. Twice sine theta cos theta is sine 2 theta. So the range is maximum when sine 2 theta is maximum, that's when plus 1. That will happen when 2 theta is 90 degrees, that theta is 45 degrees. So to get the maximum range, this angle of theta should be 45 degrees. And to get this maximum height, we can use v square equal to u square plus 2a is in the vertical direction. Between these 2 points, v is 0 at the final point. Initial velocity in the vertical direction is u sine theta square. Acceleration is minus g, and then displacement between these 2 points in the vertical direction is h. So from this you get the result. The maximum height attained is u sine theta square by 2g. So range in terms of the input u and theta, g is a constant, and the time of flight in terms of u and theta, and the maximum height attained in terms of input u and theta. So with these basic ideas, we should be able to solve this JEE Main question. I'll discuss questions which have appeared in the years 2025 and 2024. Timestamps are given in the description box. You can watch parts of video if you're running short of time. I'll discuss some 6 questions. This is the first one. 2 balls with same mass and initial velocity are projected at different angles in such a way that the maximum height reached by the first ball is 8 times higher than that of second ball. T1 and T2 are total flying times of first and second ball respectively. Then the ratio of T1 and T2 is. You can pause and run this question. Two balls, same mass, same initial velocity, but different angles. So one is thrown with say angle theta1, the second is thrown with angle theta2. And the maximum height reached by the first ball h1 is 8 times the maximum height reached by the second ball. So you have to find the flight time ratio T1 by T2. Flight time can be obtained with the vertical motion. So the relation which is relating the displacement of the time is 1 equation motion is equal to ut plus half at square. That is equal to vt minus half at square. This also can be proved easily. So for the vertical motion, between the initial and the maximum height point, s is h. Final velocity is 0 and acceleration is minus g, and the time of flight is, time duration is half the flight time between the initial point and the maximum height point. So from this, I can get h1 by h2 as T1 by T2 square. So the ratio of the flight time is square root of the ratio of the maximum height, that is square root of 8, that is 2 root 2. So option 1 is the correct answer. One is the correct answer. This is what I explained here. Two balls of same mass, same initial velocity, but angle of projection is different, theta1 and theta2. And the maximum height reached with the first one is 8 times the maximum height reached in the second ball. You have to find the ratio of the flight times. So the equation of motion we have to use is relating the displacement of the time. So this is Vt minus half at square. V at the maximum height point is 0. U is the initial velocity. So V is 0. And then acceleration is minus g. So from that you get h1 as half g t1 by 2 whole square. The time duration between this initial point and the maximum height point is half the flight time, t by 2. Similarly, h2 is t2 by 2 square. So ratio of the height is ratio of the time square. So from this you get the ratio of times as 2 root 2. This is the next question. Two projectiles are fired with same initial speed from same point on ground at angles 45 minus alpha and 45 plus alpha respectively with the horizontal direction. The ratio of maximum heights is. So maximum height, that formula, if you remember, we can use it, or you have to derive it quickly. S equal to V square equal to U square plus 2A is at the maximum height point, velocity is 0, initial velocity u sine theta whole square, acceleration is minus g, and then the displacement is h. So from this, I get the formula h equal to u sine theta square by 2g. So ratio of maximum heights h1 by h2 is U is same initial speed, and then G is same. So height is proportional to sine theta square. So sine theta 1 by sine theta 2 whole square. So H1 by H2 is sine square sine 45 plus alpha square by sine 45 minus alpha square. So that's more like a maths problem. So sine A plus B formula, sine A plus B is sine A cos alpha 1 by root 2 cos alpha plus cos 45 sine alpha divided by same thing cos minus sine. We have to square it. Square, right? So it will be cos plus sine whole square, which is cos square plus sine square 1 plus 2 cos sine. Denominator 1 minus 2 cos sine. 2 cos sine is sine 2 theta, or here it's alpha. So it's 1 plus sine 2 alpha divided by 1 minus sine 2 alpha. Sine 2 alpha is 2 sine alpha cos alpha. So option B. I made a mistake here. The first one is minus. So then this is H2 by H1. The first one is minus. So what you are finding is H1 by H2. So it's 1 minus sine by 1 plus sine. So option D. D is the correct answer. So this is I explained here. V square equal to U square plus 2a in the vertical direction. So the maximum height when the velocity is 0. Initial velocity u sine theta. Acceleration is minus g because upward direction is positive. So from this I get the ratio of the heights as u is same. So ratio of the sine square. So the first one is 45 minus alpha. Second is 45 plus alpha. So this sine a minus b formula and sine a plus b formula. And then you have to square it. Sine square plus cos square is 1. So it will become 1 minus sine 2 alpha divided by 1 plus sine 2 alpha. Third question. A particle is projected with velocity u so that its horizontal range is 3 times maximum height attained by it. The horizontal range of the particle is given by n u square by 25g. The value of n is. Range, the formula if you can remember, is u square by g sine 2 theta, and the maximum height formula is u by g. If you cannot remember the formula, you can derive it quickly. Range is u cos theta into the flight time. Flight time you can get from v equal to u plus 8 in the vertical direction. You still get this formula. This you can get from v square equal to u square plus 2as. So here in this question, range is 3 times height. So this is equal to 3 times this one. So u square by g will cancel. U square will cancel by g will cancel. So sine 2 theta equal to 3 times sine theta square. U square by g will cancel on both the sides. So this is 2 cos theta equal to 3 times sine theta. So from this I'll get range is u square by g. Height is 2g. So if you cannot remember the formula correctly, you can derive it quickly. So there will be by 2 here. So it will become 2 square. So we'll get tan theta as 4 by 3. So tan theta 4 by 3 means this is a triangle. This is theta. This is 90. So 4 by 3. 3, 4, 5 is a right angle triangle. So from the sin theta is 4 by 5 and cos theta is 3 by 5. So range can be got as u square by g. 2 sin theta is by 5 square. So it's 24 by 25 into u square by g. So n is 24. Comparing this with this given expression, n value is 24. So option D is the correct one. D is the correct answer. So range is 3 times the maximum height. That's given in the question. Range is the horizontal velocity which is uniform. U cosine the flight time. And to get h in the vertical direction, we use this v square equal to u square plus 2as. V the maximum height point is 0. U is u sine theta. And the displacement the maximum height point is h. From this, you get the formula for h as u sine theta square by 2g. Flight time you can get from v equal to u plus c in the vertical direction. So the flight time is 2 sine theta by g. So if you use this thing here, the range will come out to be u square by g sine 2 theta. That is 3 times the maximum height. That is u sine theta square by 2g. So from this you get tan theta is 4 by 3. So this means sine theta is 4 by 5 and cos theta is 3 by 5. So from this I get the range as 24 by 25 u square by g. This is the next question. A part is projected at an angle 30 degrees from the horizontal at speed 60 meter per second. The height traversed by the particle in the first second is h naught, and height traversed by in the last second is before it reaches the maximum height is h1. The ratio h naught by h1 is. So the particle is projected like this. So it reaches maximum height and then it will come down. So this angle theta is 30 degrees and the initial speed u is 60. So in the first second, so this much height is h naught. Here will be at time t equal to t by 2. So t by 2 minus 1 will be somewhere here. So this height is h1. So you have to find h1 by h naught. So in the vertical direction, You can write S equal to ut plus half at square because initial velocity is known. Initial velocity in the y direction is u sine theta, which is 60, and then sine 30 is half. So it is 30 meter per second. So in this vertical direction, S equal to ut plus half a t square. So h naught is from distance covered in the first 1 second. So h naught, you have to put t equal to 1. So it will be u minus half g because a is minus g, and then t square is 1 square. So 30 minus 5, it's 25. G is 10. Okay, and the flight time, we can calculate the vertical motion or half the flight time, v equal to u plus a t. At the maximum height point, the velocity is 0. Initial velocity is u sine theta, which is 30 minus g into t by 2. So t by 2 is half the flight time, is 3 seconds. So at this point, it is at 3 seconds. So the last 1 second is here, it is 2 seconds. So you have to h1 equal to distance traveled in 3 seconds, height y direction in 3 seconds minus the displacement in the y direction in 2 seconds. Displacement in the y direction 3 seconds, the maximum height point, which is h, minus the displacement in the y direction at 2 seconds. That you can get from, same thing, you have to put 2. U is 30 into 2 minus half g, t square is 4. So this is 220. So this is 10. Maximum height h is, that also we can find out. To find out h, we can use v square equal to u square plus 2as in the vertical direction. At the maximum height point, this is 0. So u y square, which is 30 square, minus 2g, and then h. So h is, u square is 900 by 2 into 10. So it's 45 meters. H. So 45 minus 10 is 35. Made some mistake. This is 60 and this is 20. So this is 40. 60 minus 2 into g, it's 20, so it's 40. And h is 45. So h1 is 5 meters. h1 is 5 meters. Here h0 is 25. So h0 by h1 is 5 then. h0 by h1 is 25 by 5, which is 5. The correct answer is 5. So this was explained here. In the vertical direction, AC equal to U plus half AT square. So H0 is the distance height covered in the first 1 second. So if you put T equal to 1, that will give me H0. U is U sine theta minus half acceleration is minus G, and then T square is 1 square. So from that H0 is 25 meters. So 25 meters is covered, the vertical height covered in the first second. H1 is the height covered in last 1 second. So it's a maximum height point, H minus the vertical displacement in the time, T2 minus 1. So and the flight time we can get from the vertical motion as U sine theta by G. This comes from V equal to U plus AT. That's 3 seconds. And maximum height we can get from V square plus 2AS, that's 45 meters. So here, if you put T equal to 2, half the flight time is 3, so T2 minus 51 is 1, 2. So here if you put 2, we'll get 30 into 2 minus half, G is 10, and then T square is 4. So distance height attained at the height time 2 seconds is 40. So H1 is maximum height for 45 minus 40 is 5 meters. So H0 by H1 is 5. Here's the next question. The coordinates of a particle moving in xy plane is given by x equal to 2 plus 4t and y equal to 3t plus 8t square. The motion of the particle is uniform motion along straight line, non-uniform accelerated motion, uniform accelerated motion having the motion in a straight line, uniform accelerated having motion along a parabolic path. Here the x distance is increasing linearly with time and y is a parabolic motion. So it's more like a projectile motion. So one way to do is we can eliminate time and get the relation between x and y and get the path of the motion. So from this I can get t as x minus 2 by 4. So using this thing here, I can get the relation between x and y. So y equal to 3t. Or I can take t outside, it will become 3 plus 8t. 8t is twice x minus 2 into t is common outside. T again I can put as x minus 2 by 4. So here the relation between x and y is a parabolic equation. So this is a correct one. We can simplify it, it's required, but it's not required. It's not a straight line motion. It's parabolic motion, definitely it's parabolic. It's not straight line motion. And here the acceleration is uniform because if you take x direction, dx by dt, and d square x by dt square, that's 0. Y motion will have an acceleration. So to eliminate the first equation, give me t as x minus 2 by 4. Using that in the second one, t I have to put this one and t square I have to put this square. So this is a parabolic relation between x and y. So the path is a parabola. Next question. The angle of projection for a projectile to have same horizontal range and maximum height is. So for this particular case, the range of the projectile motion, the maximum height, both are same. So range formula, if you can remember, you can use it straight away. It's u square by g sine 2 theta, with theta is the angle of projection, and the maximum height is u sine theta square by 2g. So So I have to find theta. U square can be cancelled, G can be cancelled, and then this is 2 sine cos. One sine will go, so just cos will be there, and this is sine by 2. This 2 is here, and this 2 comes from the sine to theta. So tan theta is 4. So theta is tan inverse 4. Option D is the correct one. D is the correct answer. This is what I've done here. The range and height are same for this particular motion. Range is the horizontal uniform velocity u cos theta into the flight time. And to get h, you can straight away use this formula, or you can derive it quickly. V square to v square plus 2s between the points, initial point and the maximum height point. So the maximum height point v square is 0, and u is u sine theta. So from this I get the h as this one. And flight time is from the vertical motion v equal to v plus 80. From that, if you use the thing here, I'll get tan theta equal to 4.